All right, let's do some science. I'm just placing some glass slides here, something that you've all seen before, but now, if you could watch what I'm watching, you'd see tiny little lightnings. This is the only part of the talk that'll actually have lightning. I'm going to move these little glass slides. All I've done is just cleaned it up, that's all. And I want you to pay close attention. Things will happen fast. I'm going to take some water. This is just water. I added some food coloring to it to make it colored. And we are going to place them on the surface here. And if you can cut to the projection video. Okay. Not that exciting. It just sits there. But wait a second. Watch carefully. If you look carefully, you'll notice they're talking to each other. They've just realized that something else was placed right next to it. This is just water. And they are signaling each other. They're actually computing which directions to go. And now I'm going to just play with it a little bit. Why stop at green? Let's add some color to it, literally. And I'm sure you've all played with water and food coloring before. The ironic thing is, the phenomena that I just showed you had never been seen before. What you just realize, now they don't like each other. Wait a second. The green is trying to run away, and the red's trying to chase it. Like a little cop car, and they'll slow down and start something again. What's so fascinating about what I just showed you? In the end, it's something very simple. You might have seen it in your kitchen, although you didn't. I'm sorry. I find it fascinating. It's such a simple thing. It's just water and some food coloring sitting in. And what we discovered in the system is that these systems have the capacity to communicate, signal, and literally compute. Can you go to my first slide? So I could spend the next hour actually explaining it to you what just happened right there. I spent 4 years trying to figure this out. This talk is not about that. I'm not going to tell you anything what you just saw, but I'm going to invite you to go home tonight, find a little Sharpie, some food coloring, some really clean glass. You can buy some pre-clean cover glass. Put these things on and just watch them. And I'm going to share with you a very short clip of video of what did I do for the last 4 years. And just watch this. We can make them chase each other. They can climb hills. By the way, at the back of your head, you should be thinking, where is the energy source? You can have them line up like a soldier's. And you can literally turn them into a transfixed dance. What's inside these little things are tiny little tornadoes. They're extracting energy from evaporation to turn them into physical objects. This is actually not that far from how physical cells crawl around, like your neutrophils trying to chase bacteria. Orange doesn't like blue, so they can detect each other. So they know a sense of self. And you get the point. Just go home and play tonight. But what I do want to mention today is there is a sense of wonder in some of these very obvious phenomena that lie right in front of us. If we could fundamentally understand some of these phenomena, you have the chance to actually exploit them. And that's what we did. And one of the factors that we'll talk about today is this idea that what you just saw, tiny little raindrops, these little bits of matter, that you can literally make machines out of these things. And if you're me, you think about what is the most ultimate machine that I'm going to make, which will end up being a universal Turing machine.